Welcome back to the deep dive. Today, we are undertaking what I think is a really critical mission. We're setting the stage for what our sources are unanimously describing as the fundamental re-architecture of financial services.
That's a big phrase.
It is. And we're moving far, far beyond the familiar territory of, basic chatbots that just answer questions or those simple predictive models.
Right, the ones that just flag a yes or a no.
Exactly.
That's right. I mean, for banks and financial institutions, this conversation is no longer about simple optimization.
No.
It's about strategic survival.
Okay.
And our core mission today is to do a deep dive into the strategic playbook for implementing what's called agentic AI in banking.
So we're really focused on understanding that shift.
We are. The shift from using AI as a reactive assistant, which is, frankly, where most of the current Gen AI pilots are sitting right now,
Stuck in that phase.
to embracing AI as a proactive, autonomous economic actor. And that's the definitive moment, where the intelligence doesn't just suggest something.
It does
It actually reasons through complex steps, and then it executes the action.
And there's this profound sense of urgency here, almost a paradox that's driving this whole topic. The failure to act decisively is being called an existential threat. Our sources indicate that a shocking 75% of banks are currently, and I'm quoting here, stuck in siloed pilots and proofs of concept.
Right, they can't scale.
They can't scale. So if the technology is this transformative, why are 3/4 of these institutions lagging so far behind?
Well, I think it speaks to the inherent difficulty of scaling autonomy inside a highly regulated environment. But, the stakes are just too high to stay stuck.
Okay.
The failure to deploy this kind of autonomous capability isn't just a missed opportunity for a gain.
It's a threat.
It's a direct threat to the bank's core profitability, which I think we really need to dig into. But if we look at the opportunity side first, it's massive, and it's dual-pronged.
Okay, so tell us about those two massive strategic gains.
So the first and the most immediate one is what we're calling invisible intelligence.
Invisible intelligence.
It means achieving these colossal operational efficiencies, particularly in those really high-cost, high-friction areas that are locked deep inside the middle and back office functions.
So you're talking about things like compliance.
Exactly. Think about the multi-billion-dollar costs tied up in tasks like Know Your Customer, KYC, and Anti-Money Laundering, or AML.
Right. And then the second prong, that's more the offensive strategy, right? The one that feels like the real game changer for the customer relationship.
That's proactive personalization.
Okay.
And this is all about completely revolutionizing customer engagement by anticipating their needs, not just reacting to them.
So the AI is thinking ahead for me.
It's thinking ahead. It's providing financial services that are entirely autonomous, customized down to the minute, and it effectively turbocharges this whole do-it-for-me economy for every single client.
Not just the super wealthy ones.
Not just the high-net-worth clients. For everyone.
Okay, let's unpack this monumental shift then. Agentic AI is being called the defining break from previous generations of software.
It is.
But for someone who's maybe hearing this term for the first time, what exactly is it? And how does it fundamentally differ from the Gen AI models we've all been talking about for the last 2 years?
Yeah, that's the critical question. And the key really lies in the conceptual difference between, say, assisting a human and acting autonomously to achieve a goal.
Right.
We can look at this through 3 stages of AI evolution in banking.
Let's start with the foundation. Where did we come from?
The foundation is traditional AI, or what you might call analytical AI.
Okay.
These are the systems that have been in banking for decades. They're static, they're rule-based, they're great at pattern recognition.
Like flagging a weird transaction on my credit card.
Exactly. Flagging a suspicious transaction based on historical norms, or running a static credit score using a set of predefined variables. They're reactive, they're highly effective, but, and this is the key, they're absolutely bound by their predefined rules.
They can't think outside the box.
They cannot operate outside that scope. They're a guardrail.
Then came the wave of large language models.
Right. Step 2 is generative AI, or Gen AI. It's prompt-driven, so it's still reactive.
Waiting for me to ask it something.
Exactly.
Yeah.
But its capability is generation and summarization. A customer service chatbot that answers an account balance query, or a model that drafts a summary email for a relationship manager. That's Gen AI.
So it assists the human.
It assists the human. It makes data digestible or content creation faster, but it always waits for a human prompt to begin.
And that brings us to the third step, agentic AI, where the system itself has the agency to initiate an action.
Precisely. Agentic AI systems are proactive. They are fundamentally goal-driven.
Okay.
They're defined by their ability to reason, to plan complex multi-step tasks, and then to execute them with minimal human supervision. The critical shift is that they possess agency, the ability to take the initiative to achieve an objective.
Like process this loan application.
Process this loan application without being prompted at every single stage of that process.
Autonomy sounds incredibly sophisticated, maybe even a little daunting. What's the actual architectural anatomy that lets an AI agent operate at this level? It has to be more than just a big language model.
Oh yeah, much more. It's an architecture, not magic. And it's built on 4 core capabilities. The LLM, the language model, that serves as the brain, but it needs a sophisticated body and a memory to actually act.
Okay, so let's start with that brain power and its motivation.
The first capability is goal orientation and proactivity. The agent isn't just sitting there waiting for an input field.
Right.
It's given a high-level, business-critical goal. Optimize this client's cash position, or complete the quarterly compliance report.
And it just goes.
It just goes. The agent then proactively decides the steps necessary to fulfill that objective. It anticipates variables, it identifies patterns, often before a human even recognizes the need.
And if the goal is complex, like that compliance report, it has to be able to break that mission down.
Which brings us to capability number 2. Reasoning and planning. Using that LLM as its core reasoning engine, the agent autonomously breaks down a complex goal into a logical sequence of subtasks.
So let's take that loan application example.
Perfect. The agent reasons. Step 1, I need to extract the data. Step 2, I'll verify the income sources using external APIs. Step 3, run the compliance checks. Step 4, draft the credit memo. It manages this whole multi-step execution chain logically, and it can even refine the plan if it hits a roadblock.
Now, you mentioned memory, which feels like a huge distinction from the standard stateless Gen AI prompts we're used to.
That's the third, and it's a crucial point, memory and learning.
Right.
To maintain context and improve its own performance, an agent has to retain information from past interactions. It achieves this using integrated vector databases.
Vector databases.
Yeah, unlike traditional databases that store structured data, like, rows and columns, vector databases allow the agent to store and retrieve complex contextual information. It essentially acts as the agent's short and long-term memory.
So it can adapt its approach.
Exactly. Based on what worked or what failed in the past. It moves far beyond those static rule-based models.
And finally, the capability that makes it an actor, right? The ability to actually interface with the bank's core systems. You call them the hands.
That's the fourth component. Tool use and action. An agent can't be autonomous if it's just generating text in a box.
It needs to be connected.
It must be connected to the institutional infrastructure.
Yeah.
So agents are given access to internal APIs, to software systems, to data feeds, and this allows them to execute their reasoned plan.
So it could autonomously query a ledger.
Or send a notification to a specific client, or execute a trade order, or place a block on an account. This executional capability is what turns a sophisticated model into a true autonomous actor.
When we talk about the sheer complexity of banking, multi-jurisdictional compliance, massive data flows, global trading, a single agent can't possibly handle all that.
No way.
So this naturally leads to the concept of the multi-agent system, or MAS, the orchestra, as you call it.
The MAS architecture is absolutely essential. We shouldn't think of these agents as solitary geniuses. We should really think of them as specialized human teams.
Okay.
And this architecture allows for massive robustness and, importantly, accountability, which is crucial for a regulated environment.
Okay, let's use a real-world complex process. Walk us through how a multi-agent squad would tackle a task like an AML investigation where human collaboration is currently mandatory.
Certainly. So the task is complex, right? Determine if a flagged transaction is legitimate or potentially tied to illicit activity.
Right.
You deploy 5 specialized agents.
Okay.
Agent 1, Agent A is the reviewer. It receives the initial transaction alert and understands the core rule that was violated.
Got it.
Then Agent B, the data gatherer, it connects to the bank's internal systems to pull the full customer profile, all the transaction history, associated accounts, and centralizes that data.
So it's building the case file.
Exactly. Then Agent C, the researcher, goes external. This agent scans proprietary and public data sources for adverse media, it checks sanctions lists, and it looks for ultimate beneficial ownership irregularities.
UBOs.
The UBOs. Finally, Agent D, the report writer. It synthesizes all the findings from Agents A, B, and C into a structured, Final, suspicious activity report, a SAR template, ready for human review.
That's a highly efficient team structure right there, but you mentioned a fifth agent that specifically addresses that audit and trust requirement.
Yes, and this is the critical player. Agent E is the critic, or the validator.
The critic.
This is a specialized oversight agent designed to review the output of the entire team for accuracy, for completeness, and for logical consistency.
So it's checking the other AI's work.
It's checking the work of the others before the package is ever escalated to a human compliance officer. This architecture minimizes blind spots and, crucially, it creates an auditable trail, which banks call the decision chain log.
A decision chain log.
It records all the reasoning, all the data inputs, and all the handoffs between the agents.
So we have these powerful enterprise agents working internally for the bank, the analysts, the credit drafters, the AML squads.
Right.
But the real disruption gets externalized when we look at this emerging agent-to-agent or A2A economy.
This is the future competitive battlefield. This technology creates two distinct classes of agents. You have the bank's enterprise agents, and you have the autonomous personal agents working ruthlessly for the customer.
Okay.
And the A2A economy is the future marketplace, where these two systems interact programmatically.
So if I'm understanding this correctly, my future interaction with my bank won't be me logging into an app.
Probably not.
It'll be my personal AI agent communicating directly with their enterprise agent through an API.
That is the long-term view. The interaction will be programmatic, it'll be high-speed, and it will be entirely focused on optimizing cost and return for you. Sources describe this as the foundation of agentic commerce, where a customer's agent at every single transaction point conducts a kind of micro-auction for the best interest rate or the best reward or the best price.
Which forces banks to be agent-ready.
They have to be. If their enterprise agents can't efficiently, securely, and competitively engage with customer agents, they simply lose the business, programmatically.
This shift from definition to necessity really sets up our next segment. We need to move away from the conceptual to the commercial.
The bottom line.
The bottom line. Why must the C-suite prioritize this right now? Let's start with the immediate, quantifiable value and address this so-called Gen AI paradox.
Yeah, this paradox is why so many executives are still skeptical about scaling their AI investment.
Okay.
Studies show that while roughly 80% of companies are adopting Gen AI, nearly the same number, 80%, report no significant measurable bottom line impact.
So why does that huge gap exist?
It's because general-purpose Gen AI tools deliver these diffuse horizontal gains.
What do you mean by that?
Well, they might shave 5 minutes off 100 different tasks performed by 100 different people. The gains are real, but they're very hard to aggregate, very hard to measure, and they rarely result in, FTE reductions or massive operational savings.
So how does agentic AI break that pattern of soft, unquantifiable returns?
It breaks the paradox by enabling deep vertical automation of entire complex end-to-end processes.
Vertical automation.
The value isn't assisting a human with one task. It's deploying an autonomous agent squad to complete 30 to 60% of an entire workflow, like drafting a credit memo or processing a compliance file.
And that you can measure.
That translates directly into measurable hard ROI. If you cut the total time required for a complex credit approval by 30%, that is a hard dollar measurable improvement in throughput and capital efficiency.
Okay, let's talk about the intelligent efficiency engine and really quantify some of that cost reduction. As you mentioned, compliance costs, especially KYC and AML, are just staggering. What kind of numbers are we talking about?
The figures are mind-boggling, and it's because the effort is so manual. Banks currently dedicate somewhere between 10 and 15% of their total full-time employees, their FTEs, specifically to KYC, AML, and related compliance functions. Globally.
10 to 15% of the entire workforce.
We're talking about billions and billions of dollars spent simply maintaining regulatory hygiene.
And the agentic AI factory model fundamentally alters that cost structure.
It does. It completely moves the human expert's role from doing the grinding manual data collection and validation to supervising a digital workforce.
So one person manages many agents.
A large global bank, cited in a McKinsey analysis, built an AI factory, where one human expert could effectively oversee and approve the work of 20 or more AI agents.
Wow.
The agents handle the 80% of routine end-to-end workflow, and that focuses the human only on the complex exceptions.
So to put that in perspective, what does that kind of organizational shift do to the productivity metrics in those high-cost centers?
Because the bottleneck shifts entirely to the human's ability to validate rather than create, The productivity gains are projected to be anywhere from 200% to 2,000%.
2,000%.
In high-friction functions like KYCML, this is a dramatic alteration of the bank's operational leverage.
And there are other benefits, too.
That's for sure. Reports indicate that banks leveraging this kind of automation can get an overall 30% productivity boost in back-office ops. And by speeding up time to market and freeing up resources, they can unlock 20 to 30% in annual revenue growth just through efficiency gains.
That's the defense, the cost containment. Now for the offense. The new revenue frontier through proactive personalization. We're talking about moving way beyond basic recommendations here.
This is the strategic pivot. Traditional personalization is reactive. It's based on past behavior.
Because you click this, you might like that.
Because you clicked on this mutual fund, we recommend that similar mutual fund. Agentic personalization is proactive, it's holistic, and it's execution-oriented. It anticipates your needs, and it acts on them.
Okay, give us an example that really illustrates that shift from a reactive suggestion to a proactive action on my behalf.
Okay, think about wealth management. A traditional system might suggest a fund reallocation.
Right.
An agentic system, after analyzing your entire financial picture spending patterns, income, tax situation, long-term goals, it identifies that you're paying too much interest on a student loan compared to competitors.
Right.
Now, the agent doesn't just send you an email. It can proactively compile the necessary paperwork and, with pre-approved delegated authority, it can submit a refinancing application on your behalf. It might even monitor the market for the optimal rate to lock in.
So it's democratizing that high-level bespoke advisory service.
That's exactly it.
I find the microloan example for driving customer lifetime value, or CLV, particularly compelling because it's so granular and targeted.
It's highly effective because it removes friction entirely. An agent autonomously detects a salary credit and confirms you have stable cash flow.
Okay.
It checks real-time repayment signals and recognizes an optimized moment to offer a perfectly timed tiny microloan for a specific immediate need, maybe a utility bill or a minor car repair.
And that immediate high-relevance intervention.
It significantly improves customer perception, retention, and ultimately their lifetime value to the bank.
This all sounds great for the customer, but it forces us to confront the existential defensive case. If I, the customer, am being optimized 24/7, how does that impact the bank's traditional profit model?
Yes.
McKinsey's end of inertia thesis is built on the fact that banks currently profit from my laziness.
That inertia is the foundation of retail banking profitability, and agentic AI is a directed missile aimed right at it.
Wow.
Banks make money from the margin between what consumers could do, optimize their savings, minimize fees, and what they actually do.
Which is leave cash in low-yield checking accounts, forget to redeem rewards.
Exactly. Autonomous agents eliminate that gap.
Let's break down that threat, starting with the deposits. How does a personal agent attack the deposit moat?
The threat is stark and it is direct. Banks rely on low-cost deposits money just sitting in current accounts or low-yield savings.
Right.
Autonomous personal agents will monitor those balances nonstop, comparing the yield against money market accounts or high-yield savings products across the entire market.
And it will move my money for me.
It will ruthlessly sweep idle cash out of those low-yield accounts and into the highest possible return vehicle, only returning funds just in time to cover pending transactions.
That destroys deposit stickiness.
It destroys deposit stickiness, it erodes the bank's low-cost funding base, and it severely compresses their net interest margins, their NIMs. The customer benefits, but the bank's core profitability suffers immediately.
And credit cards, which rely so heavily on high revolving balances and unredeemed rewards, they're equally at risk, aren't they?
Absolutely. The personal agent's goal is to optimize for the consumer's financial outcome, period. It has no brand loyalty.
So what does it do?
It will autonomously direct every single purchase to the card that offers the best reward for that specific category: gas, groceries, travel. It will automatically detect when better introductory offers are available and trigger new card applications.
And the really critical part.
Most critically, it will automatically roll existing balances onto zero-interest promotional cards before the current promotional period expires, minimizing the interest you pay and destroying the high-margin revolving debt revenue stream for the bank.
The implication here is crystal clear. If my bank doesn't provide a world-class optimizing agent for me,
Someone else will.
I will get one from a big tech competitor or a fintech, and that third-party agent will then systematically optimize away my bank's core revenue streams.
That is the defensive imperative. The implementation of enterprise agents is required not just for growth, but to defend the balance sheet against autonomous consumer agents whose only goal is to drain profit centers. This is a game of architectural preparedness.
We've established the strategy efficiency on one side, defense on the other. Now let's get granular and really look at the battlefield. We're going to break down how agentic AI applies across the entire banking operation, starting with the customer-facing services.
Right, starting with the front office and the proactive customer relationship. The evolution here is from that informational chatbot to what we're calling the hyper-personalized financial assistant. That's the new flagship offering.
And what's the capability that allows this new assistant to go beyond the limits of current models, like, say, Bank of America's Erica?
It's the combination of tool use and reasoning. These new agents can leverage open banking APIs to get a holistic view of all of the customer's financial movements, not just what's happening within the bank's own walls.
So it can see everything.
It sees everything. It can predict cash flow shortfalls, model long-term outcomes, and, crucially, autonomously execute complex tasks. Rebalancing retirement portfolios based on market signals, optimizing tax loss harvesting, or proactively initiating an application for a home equity line of credit. It democratizes high net worth advice and makes it programmatic and scalable.
This changes the entire customer service dynamic, moving from reacting to an angry phone call to what you're calling proactive customer service.
Exactly. Gartner predicts that by 2029, autonomous agents will handle 80% of common customer service issues without any human involvement.
80%?
The agent monitors behavior. It identifies potential friction points, for example, seeing a pattern of low balances that's heading toward an overdraft, and it proactively acts.
So it might sweep funds for me?
It might sweep funds or send a protective automated alert addressing the issue before the customer is even charged a fee or even recognizes there's a problem. It's friction elimination as a service.
And looking even further ahead to future commercial interactions, we have autonomous negotiation and agentic commerce. This sounds like high-stakes AI on AI interaction.
It is. We're already seeing development in agents that are capable of negotiating complex terms, like loan interest rates or credit card limits, on behalf of the consumer.
Wow.
But the real structural change is being built by ecosystem players like Stripe. They've co-developed something called the Agentic Commerce Protocol, or ACP, with OpenAI.
What is that?
It's essentially an open standard that allows AI agents, like a highly sophisticated version of ChatGPT, to programmatically and autonomously buy products, enter into contracts, or manage subscriptions.
So banks have to be ready to sell to robots.
Banks must be architecturally ready to sell their products, their loans, their insurance, their credit, programmatically to these non-human buyers.
Let's move to the middle office, the autonomous risk and compliance engine. This is where the sheer volume of manual labor makes that ROI potential highest.
This area is transitioning from merely flagging risks to managing the complete risk workflow from end to end.
So with fraud, for example.
In fraud, traditional AI flags fraud. That creates a queue for a human analyst. Agentic AI enables autonomous fraud response.
How does that work?
A multi-agent system continuously monitors transactions. If an alert triggers, the agents cross-check results across multiple systems, which reduces false alarms. One case study showed a 40% reduction in false positives.
And then it acts.
Upon autonomous confirmation of the threat, the system autonomously freezes the card, sends the real-time alert to the customer, and initiates the dispute and recovery process. The human role is just to manage the most complex 1% of cases.
And then there's the high-volume behemoth, KYC ML lifecycle automation. This is the engine for efficiency. Can you detail that end-to-end automation?
This is the definitive AI factory model. The agent squad executes the full process. It starts with data extraction from documents, validation of complex corporate structures like ultimate beneficial owners or UBOs,
Right.
immediate sanctions screening, continuous adverse media checks across global sources, and finally, compiling the standardized KYC file.
And this isn't just data input.
No, the agents are performing reasoning and validation checks at every single stage. This shifts the human compliance officer entirely to a validation and governance role, which is where you get those massive reported productivity gains.
Risk management itself also becomes a continuous dynamic process rather than, say, a static annual review.
Precisely. In credit, the shift is from backward-looking to real-time, continuous monitoring. Advanced systems, like those implemented at Wells Fargo, can process and evaluate over 3,000 unique data points.
Far more than a human could track.
Way more. And they do it in under 60 seconds to make an initial loan decision. Agents draft the initial credit memo, and then post-approval, they continuously monitor the borrower's adherence to loan covenants,
So they're watching for trouble.
proactively flagging any sign of financial distress or potential default warning long before a human analyst would ever detect it.
And the application in trading also pushes the boundary of that multi-agent collaboration.
It really does. It creates a digital version of the trading floor.
Yeah.
Firms like RBC are using live production agents that not only execute trades, but learn and adapt based on market outcomes.
And the most advanced systems.
The most advanced multi-agent systems simulate a collaborative trading desk. You might have one agent acting as the fundamental analyst, another as the sentiment analyst, and a third as the execution agent.
And they debate.
They debate and synthesize conflicting insights. For example, comparing positive fundamentals against bearish social media sentiment before the execution agent is given the final green light to act.
Finally, we get to the back office, the invisible intelligence factory. This is where technology debt is addressed and these complex, high-volume processes get automated.
And this is the crucial evolution from, let's say, dumb robotic process automation, RPA, to intelligent agents.
What's the difference?
Traditional RPA executes simple, predefined, rules-based tasks, if A, then B. An intelligent agent, however, can handle variability and make autonomous decisions. A Deloitte analysis pointed out that an agent can elevate a simple cash sweep into a dynamic liquidity optimizer, making autonomous, complex decisions on where to place funds based on real-time pricing and hedging opportunities.
And this is being applied elsewhere.
It's being applied to end-to-end mortgage servicing, claims processing, and complex reconciliation.
And what about that challenge of technical debt, all those legacy COBOL systems? Can agents actually help fix that fundamental infrastructure problem?
Yes, through what some are calling digital engineers. The Citi case study is a prime example here.
What did they do?
They deployed AI agents tasked with accessing legacy code repositories, autonomously finding and fixing low-complexity code issues, like updating dependencies or applying simple patches, and then submitting detailed completion reports to human engineering managers.
So they have a digital workforce paying down tech debt.
24/7. Freeing up expensive human engineers for high-value new development. Agents are also used extensively in autonomous reporting, where they can aggregate data from disparate legacy systems to compile complex regulatory reports, a process that's often 80 to 90% cheaper than relying on manual data consolidation.
The strategic case is compelling, but the move from a handful of siloed pilots to enterprise scale is the great stumbling block for those 75% of institutions we mentioned at the top.
It is.
We need a practical playbook, starting with the necessary architectural foundation. Agentic AI demands a complete technology stack for autonomy.
It's entirely an architectural challenge. We're talking about 3 distinct layers that have to be integrated seamlessly.
Okay, layer 1, the intelligence.
That's the agent and model layer, or the brain. This combines large foundational LLMs with specialized open-source agentic frameworks.
Like LangChain or Crew AI.
Exactly. LangChain, Crew AI, Microsoft Autogen. These frameworks provide the scaffolding that enables the agent to do its reasoning, its planning, and its tool orchestration. This is where the core intelligence lives.
Okay, layer 2 is memory and speed.
That's the infrastructure layer, or the body. This requires high-performance cloud compute and low-latency inference systems to ensure real-time decision-making. And, as we discussed, crucial to this layer are the vector databases.
Which act as the agent's memory.
They're necessary for the agent's memory. Instead of storing structured data, these databases store the context and the meaning of past interactions, enabling the agent to retain that long-term memory and adapt its behavior based on experience.
And layer 3, the capability to act in the real world.
The application layer, or the hands. This is the most practical layer for banking operations.
Okay.
This layer is the network of APIs and tools that connect the agent's brain to internal and external systems. The core ledger, the CRM, the global payments networks. This connectivity is what enables the agent to execute its plan.
So without the hands.
Without robust tool use, the agent is just a very, very smart chatbot.
For incumbent banks, the biggest technical friction point has to be the interaction between these modern AI systems and those ancient, siloed legacy systems, the COBOL cores. You can't just rip and replace that.
No, it's too costly, too risky.
So what's the viable strategy for solving this legacy system challenge?
The viable capital-efficient strategy is the AI fabric overlay.
An overlay.
You don't replace the core, You build a unifying layer over it. This involves first creating a data fabric that unifies and standardizes the view of all the customer and transaction data that's siloed in those legacy systems.
And then the AI sits on top of that.
Then the AI fabric, the layer of autonomous agents, sits on top, accessing and interacting with the core ledger through standardized APIs provided by the data fabric without needing to destabilize the core operating system.
The Plaid example is fascinating here because it shows the agent fixing its own connections to those legacy systems.
It's a perfect illustration of agentifying the core without replacing it. Plaid deployed an internal agent they called Fix My Connection.
Agent do.
This agent proactively and automatically identifies and repairs common issues with its own API integrations to legacy bank systems. This self-healing architecture, achieved via an agent acting as an overlay, reduced connection downtime by 90%.
Oh.
It proves that modern autonomy can effectively manage and stabilize historical infrastructure.
So moving to the rollout, a highly regulated industry like banking can't just deploy autonomous decision-making overnight. A risk-managed, phased strategy is critical.
Absolute.
We're talking about the crawl, walk, run approach centered on defining the degree of human oversight.
This phased approach is mandatory for building trust, demonstrating compliance, and establishing governance.
Tell us about phase 1, the crawl.
Phase 1 is pilot, high impact, low risk. The focus is on internal processes that don't involve direct customer money movement or sensitive regulatory decisions.
For example.
Autonomous internal reporting, or deploying those digital engineer agents like Citi did to fix legacy code. This builds internal confidence and establishes the core tech stack without taking on high risk.
Then we move to walk, where the risk increases a bit, but so does the value. This introduces the human in the loop, or HITL, model.
Right. Phase 2 is scale with human in the loop. In this model, the agent completes the complex work, the reasoning, planning, and drafting, but a human validates every output before execution.
So in AML.
In AML KYC, the agent squad drafts the full file, but the human compliance officer provides the final approval. In credit, the agent drafts the 100-page credit memo, and the senior relationship manager reviews the strategic context before signing off. The agent assists the human by doing all the heavy lifting.
And finally, the ultimate goal, run. This introduces the next level of autonomy with the human above the loop, or HATL model.
Phase 3 is a deploy human above the loop. This is where you achieve governed autonomy.
So the agent makes the decision.
The agent executes the entire process and the decision, but within extremely strict predefined guardrails and risk limits. Humans move above the loop to monitor performance and only manage high-risk exceptions that fall outside the agent's predefined bounds.
And where is this applicable?
This is applicable to real-time autonomous fraud blocking within a certain dollar limit, or automated lending for low-risk, pre-qualified, small-dollar loans.
It's highly encouraging that these concepts are moving from theory into production. Where are the pioneers in practice making real headway?
We're seeing production-grade deployments across the largest institutions. JPMorgan Chase, for example, is leveraging their internal AI factory platform for end-to-end automation of highly complex KYC/ML workflows.
And in wealth management.
They're deploying agents for autonomous portfolio rebalancing in their wealth divisions.
And in risk and credit.
Wells Fargo is running sophisticated AI credit systems that analyze thousands of data points in seconds to speed up lending decisions. They're also utilizing real-time autonomous fraud response systems that execute the full workflow.
Freeze, alert, dispute.
Freeze the card, alert the customer, and initiate the dispute, all without human intervention. This demonstrates that HATL model in action for real-time risk management.
And of course, the architects of the A2A economy, like Stripe.
Stripe's development of the Agentic Commerce Protocol is a clear strategic move. They are building the foundational standard for AI agents to buy and sell programmatically. They're ensuring the pipes are laid for agent-to-agent interactions, which reinforces why all financial institutions need to be architecturally ready to engage in this new form of commerce.
This is the critical juncture for regulated industries. Autonomy introduces agency, and agency introduces risk.
A lot of risk.
The governance framework is the single biggest blocker for moving from pilot to scale because autonomy creates an entirely new class of risk that traditional frameworks just cannot handle.
That is the absolute truth. The initial hurdle is the regulatory gauntlet, specifically tackling the black box problem. The opaque, complex decision-making process inside many of these LLMs conflicts directly with mandated banking regulations that require transparency and explainability.
Can you detail that conflict? How does opacity violate established regulatory requirements?
The key conflict is over credit decisions. Regulations from the CSPB and the OCC mandate that if a customer is denied credit, the bank has to provide a specific, accurate, adverse action notice detailing why the decision was made.
And the model decided it is not an acceptable answer.
It is not a sufficient answer. If an opaque AI agent can't produce a clear, auditable, and specific reason code for denying a loan, it creates an immediate, massive compliance risk under existing U.S. law.
And regulators aren't waiting for new agentic AI rules, they're just applying old frameworks to it.
They're simply applying legacy model risk management guidance to this new technology. Specifically, guidance like SR 11.7, which governs model inventory validation and testing, will be applied to these agentic systems.
Which
Demands documentation, detailed logs of feature importance, what inputs drove the decision, and independent testing for bias and fairness. Trying to apply these requirements to a self-learning, multi-step, opaque agent architecture is profoundly difficult.
But the Bank Policy Institute, the BPI, raises a really potent counterargument about the danger of regulatory paralysis here.
They do. The BPI argues that the overlooked risk is regulatory inaction and institutional caution.
Okay.
They state that overly slow or overly complex model review processes effectively prevent banks from deploying the critical defensive AI needed to combat sophisticated AI-driven criminal threats that are evolving so rapidly.
So if banks are too slow to adopt autonomous fraud agents because of regulatory friction,
They're left vulnerable to AI-powered attacks. It's a real catch-22.
let's pivot to security. If an autonomous agent has the power to move money and access customer files, it is essentially a highly privileged digital employee. This introduces the new vector for security, the autonomous insider threat.
An agent is the ultimate insider. It never sleeps. It has programmatic access. And this power is being leveraged by malicious actors.
How so?
We're seeing a significant rise in synthetic identity risk, where productized agentic AI is used to autonomously generate highly realistic fake documents and entire sophisticated synthetic identities to apply for loans or open accounts at scale.
And these malicious agents can even be trained.
They're even trained to mimic good customer behavior over time to evade detection systems, acting as sleeper agents inside the bank systems.
The multi-agent architecture, while robust for business, also introduces new failure modes, doesn't it?
It does. We have the risk of cascading failures or chain vulnerabilities. If a planning agent, for instance, makes a flawed decision or extracts corrupted data, that error is passed down the chain.
So it infects the other agents.
It causes all subsequent agents, the data gatherer, the researcher, the report writer, to make corrupted decisions based on that initial bad input. It's a critical vulnerability.
And that's related to data corruption propagation.
Right. If an agent ingests poison data, maybe a subtle adversarial attack, that bad data silently affects decisions across the entire agent network in a catastrophic domino effect.
And regarding privacy, how do we ensure agents aren't sharing sensitive data unintentionally?
There's a significant risk of untraceable data leakage. Agents are designed for high-speed data exchange with external APIs to complete their goals.
Right.
If the agent's guardrails are improperly set, it might inadvertently share unnecessary personally identifiable information, PII, with an external tool or API without any oversight.
And because it's programmatic, it's hard to trace.
Exactly. The data leak can be obscured and bypass traditional internal audit trails.
So if traditional AI governance is insufficient, banks have to adopt a new framework built for autonomy.
They do. And the industry is converging on specialized frameworks, notably the Finos AI Governance Framework, or AIGF version 2.0.
And what's special about that?
This framework is designed specifically for regulated entities. It introduces an agentic AI risk catalog with active runtime defenses for emerging threats that traditional frameworks just miss, like prompt injection and memory poisoning.
Okay, let's detail the practical mitigation strategies that address both regulatory compliance and security.
To solve that black box problem, banks must mandate decision chain logging.
Which you mentioned earlier.
It means logging the agent's entire reasoning process, all the intermediate steps, the thoughts generated by the LLM, the data inputs, and the executed actions. It provides a full audit trail for compliance.
But how do you provide the actual reason codes for an opaque decision?
We use specialized tools called explainable AI or XAI techniques.
Like Lime and Shea.
When we talk about Lime or Shape, these are advanced post hoc techniques that essentially peek inside the black box and show us precisely which inputs or data features drove a specific decision.
And that allows the bank to produce those mandated reason codes
Exactly. For adverse actions.
and to manage that autonomous insider threat.
We have to enforce strict API guardrails. This means applying the cybersecurity principle of least privilege access and doing it rigorously.
So the agent only gets what it needs.
An agent only has access to the specific data and tools absolutely essential for its immediate goal, and nothing more. And finally, we return to human above-the-loop oversight.
So the mission control dashboard.
A mission control style dashboard for supervisors to monitor real-time agent performance, and most importantly, a mandatory, globally enforceable kill switch for any perceived rogue or anomalous agent behavior.
We've covered the technology and the governance. Now for the cultural and organizational challenge, which is often the most profound and time-consuming part of any transformation.
The people part.
The people part. The autonomous digital workforce fundamentally redefines the roles of human employees.
This is a fundamental paradigm shift. It changes what it means to be a valuable employee in a bank. The core transformation is that the human worker moves definitively above the loop.
So their role shifts away from doing the work.
It shifts away from doing the repetitive process execution, the data entry, the routine checks, to managing, supervising, and orchestrating the autonomous AI workforce.
So the human expert becomes a manager of digital employees. What are their two core focuses in this new supervisory model?
Their time gets concentrated into two critical areas where human judgment remains absolutely indispensable.
Okay, the first.
First, validation and exception handling. Managing the less than 20% of high-complexity, unstructured, or ambiguous exceptions that the AI can't handle, and providing that final strategic validation for mission-critical outputs.
And the second focus?
Second is coaching. Providing expert feedback on bad outputs, a process we often call reinforcement learning from human feedback, or RLHF, to continuously correct and fine-tune the agent's performance over time.
This means the entire skill set required by the human workforce is changing dramatically. It's moving away from generalist data science skills into this nuanced, deep expertise.
Absolutely. The most valuable skills are concentrating on high judgment functions. The three critical new skill sets are: 1, AI literacy.
Which means?
A deep, practical understanding of agent workflows, their inputs, how they fail, and how to debug their reasoning.
Okay, second.
2, deep domain-specific subject matter expertise. Since the agents automate the easy 80% of routine work, human value concentrates in the 20% of complex exceptions. The human must have the deep domain knowledge to instinctively know when an agent's output just feels wrong.
And third?
And 3, integrative problem solving. The ability to design and optimize complex, cross-functional agent workflows that span organizational silos and involve integrating multiple agents and human validation points.
This shift must be creating a host of new, high-value roles required specifically to manage this digital workforce, roles that didn't even exist 5 years ago.
Indeed. We're seeing the emergence of 3 critical new functions that banks must be staffing and training for immediately.
Role number 1. The conductor of the orchestra.
The AI agent orchestrator. This person is the chief process designer. They're responsible for integrating complex, cross-functional agent teams to achieve a holistic business outcome.
So they're the architect of the workflow.
They're the architect of the workflow. For example, managing the end-to-end multi-agent system that handles the entire KYC lifecycle across 3 different geographies.
Okay, role number 2 is the governance guardrail.
That's the AI agent auditor. This is a specialized risk and compliance function.
What do they do?
They are responsible for tracing the agent's decision chain through the logs, conducting mandatory fairness and bias audits, and ensuring that all autonomous actions are fully compliant with regulations like SR 11-7. They keep the agent's audit ready.
And finally, the role that integrates the human domain expert directly into the machine learning loop.
That's the AI agent coach or trainer. This is the new title for the subject matter expert. Their job is not to do the work.
It's to teach the AI.
It's to work directly with the agent squads, providing the expert feedback, that RLHF, necessary to correct mistakes, and fine-tune nuanced task performance in highly sensitive areas like complex credit structuring or nuanced compliance interpretations.
The conclusion here seems to be that the cultural and organizational retooling will be the longest and most difficult part of this transformation.
It always is.
Which means banks have to start reskilling programs today, not tomorrow.
The technology adoption curve is moving much faster than the talent development curve. Banks must proactively identify and begin training these new roles, the orchestrators, the auditors, the coaches, if they hope to move beyond those ineffective siloed pilots and truly embrace the governed, human-above-the-loop operating model at enterprise scale.
We've covered the full spectrum of agentic AI in banking, from the technical anatomy of an autonomous actor and the existential threat to core profits, right through to the profound cultural shifts it demands. If we had to summarize the core strategic recommendations for financial leadership right now, what would they be?
Okay, first, I think leadership has to recognize and counter this AI reckoning, the fact that 75% of the industry is stuck. They need a unified top-down strategy that mandates this transition. Second, they must stop prioritizing features and start building the foundation, the AI factory infrastructure.
So the data fabric, the API layer.
The data fabric overlay, the API layer, and critically, an agentic native governance framework like Finos AGF 2.0 immediately.
And fundamentally, that mandate has to include a change in thinking, shifting from simply automating individual tasks to process re-architecture.
Absolutely. They must redesign their end-to-end core workflows, KYC, credit service with autonomous agents positioned at the core, not merely bolted onto existing and often broken manual processes.
The goal is the governed human above the loop model.
The goal is that HATL model, preserving human judgment for oversight and complex exceptions while maximizing digital throughput.
If we synthesize everything we've discussed today, what defines the future success story in this new autonomous paradigm?
The future of banking will not be defined by the institutions that deploy the most agents. It will be defined by those who best orchestrate the governed collaboration between their human and their digital workforces.
So it's about the partnership.
The successful bank will be the one that manages these autonomous systems most safely, effectively, and accountably, ensuring that human judgment remains the ultimate authority within that human above-the-loop model.
That sets up our final provocative thought for you, the learner. If autonomous personal agents are constantly conducting a micro-option at every checkout and ruthlessly optimizing away deposit stickiness, what does brand loyalty truly mean in the emerging A2A economy? And what incentive can a bank possibly offer to secure an agent's business when the interaction is programmed purely for the lowest cost and the highest return? Something to mull over as we watch the financial world fundamentally transform around us.